So coming to the second problem, a 230 by 460 volts transformer has a primary resistance of 0.2 and the reactance of 0.5 and the corresponding values of secondary are 0.75 and 1.8. So here the primary induced EMF is 230 volts and the secondary induced EMF is 460 volts and the primary resistance R1 is equal to 0.2 ohms and the reactance is 0.5 ohms and now R2 is 0.75 ohms and the X2 value is 1.8 ohms. Find the secondary terminal voltage. Is asking V2 when supplying 10 amperes, that means the load current is 10 amperes at 0.8 power factor, as cos phi 2 is equal to 0.8. So power factor lagging. So first of all you should write the formula. Percentage voltage regulation for a lagging power factor is I2 R02 cos phi 2 plus I2 X02 sin phi 2 divided by E2. The R02 is equal to R2 plus K square times of R1, and from this we can calculate the transformation ratio where K is equal to E2 by E1, and 230 by 460 means it is a step up transformer. 460 by 230, the K value is now 2. So now R2 is 0.75 plus 2 whole square into R1 is 0.2. So 0.75 plus 4 into 0.2 is 0.8. The value which I am getting is 1.55 ohms. And similarly you can calculate X02 is equal to X2 plus K square times of X1. What is X2? What is the X2 value? The X2 value is 1.8 plus 2 whole square into 0.75. So 4 into 0.75. So finally I got it as 3.8 ohms. So 3.8 ohms. And then finally you can substitute here. So I2 value is 10 into 1.55 into power factor is 0.8 plus 10 into this is 3.8 into 0.6 divided by E2 is 460. Then I will get the percentage voltage regulation. So if you calculate this, then finally I got it as 7.65 percentage. He is asking a terminal voltage. So E2 minus V2 is equal to I2 R02 cos phi 2 plus I2 X02 sin phi 2. I2 is 10, R02 is, what is R02? R02 is 1.55. R02 is 1.55 into 0.8 plus 10 into the X02 value is 3.8 into 0.6. So then I am getting the drop is 35.2 volts. We know that E2 is 460 is minus V2 is equal to 35.2. Then V2 is equal to 460 minus 35.2. Finally I got the answer 424.8 volts. Coming to the next problem, calculate the regulation of a transformer in which the ohmic loss is 1% of the output and the reactance drop is 4% of the voltage. Ohmic loss, that means full load copper loss, percentage full load copper loss is equal to 1%. So as we have seen in the derivation, that should be equal to percentage R, and percentage X is equal to 4%. Then you can calculate the voltage regulation for 0.8 lagging power factor. Percentage voltage regulation is equal to percentage R cos phi plus percentage X sin phi. Plus is for lagging power factor. So substitute here 1 into 0.8 plus 4 into 0.6, 2.4 plus 0.8, that should be equal to 3.2 percentage. And the second is for unity power factor. Second is for unity power factor. Percentage voltage regulation is equal to percentage R. The cos phi value is 1. So into 1 plus percentage X into, if cos phi is 1, sin phi is 0, that should be equal to percentage R. So that is 1% only. And the third bit is 0.8 leading power factor. So now the percentage voltage regulation is equal to percentage R cos phi minus percentage X sin phi. So R is 1 into 0.8 minus percentage reactance is 4 into 0.6. So 0.8 minus 2.4, that should be equal to minus 1.6%. So this is for 0.8 leading power factor. And this problem is very important, and this problem is repeated in so many times, and this is a somewhat twisty problem, and this problem is appeared in one of the gate examination also.